here we go again. By popular demand, today is a shorter episode on testing. I'm gonna claim it to be part of the educational series, which technically means that it's shorter, easier, requires no, well, or rather lower barrier to enter, and should be useful overall for broader audiences. No tricks. Yes, we do have a chance to actually have it done within 45-50 minutes, which would be a record. Let's start it. My objective today is to cover software testing from the standpoint of a software developer. So full disclosure, I asked ChatGPT what kinds of tests does it know. It gave me 25 options. So it turns out the topic is quite big. People call lots of things software testing, and people call lots of things different types of tests. And it happens to me all the time, both at the meetup and at work. When people start arguing about seemingly nonsensical topics, like, hey, is this a functional test, or an end-to-end test, or a regression test? At the same time, some important topics that should be covered are not covered. So, as it always happens, I view my mission on this planet to bring clarity into these conversations. Hence, this is the episode. We will primarily focus on two things: testing business logic. As in, there's a team, it has a Jira epic or whatnot, it's got plenty of tasks, and they need to be completed and verified that they're completed correctly. That's where testing comes into play primarily in my life. And at a certain point, when individual components work well, we need to test that they can function well together. That's where you, in my book, that's when you graduate from unit tests to integration tests and end-to-end tests overall. At the lowest possible level, you just test local contracts. That's what most people can do. That's part of the interview playbook for juniors. How do you test A plus B? How do you test that you don't have any like off by ones in your for loops? What if something is of zero length? That's unit, like lowest level unit testing. Eventually you graduate into integration testing of multiple components together. That's where you begin asking questions like, do I mock this? Do I emulate the previous version? Do I have a Docker compose topology to spin up some local database or whatnot? And ultimately this gets all the way to the end-to-end test, which may even include front-end or even real physical front-end. My favorite example here is testing front-ends in the browser is sort of mature these days. Testing mobile applications natively is actually quite tricky, and there are frameworks where you can have a physical Android device. Like I've seen racks of different Android phones equipped with certain software, so they pretty much emulate clicks, emulate taps, and then they like OCR the results, and the test is passed once you know for a fact you can make a number of clicks and get to a certain number of taps and get to a certain page result or whatnot. That's to me a proper end-to-end test. We'll touch briefly on the ways to test the front end. What we will not cover, we will not do A/B testing. To me, it's a totally different conversation. It's really fun, it's really interesting, especially when money is involved. Like A/B testing ads, A/B testing, like different entry screens, different promotional materials. To me, it's really far from the actual testing topic. Performance testing, we got an episode called benchmarking production systems, so don't need to go there. There's a special sort of test that has to do with not helping yourself or your company, but helping your company appear well to the external audience. Like if you're in a regulated industry, you need to test your code that it complies with certain rules and regulations. That's also not something I'm going to cover. That's one of those few cases where you actually may want to test in a slightly less diligent way to not set yourself up, so that you know, like, you can debug stuff yourself, but things are presumably working for the like broader authority. I'm not going to talk about that. That's an ugly topic. I hope this can be seen. I can move the thing is here. I'll move them here. It's just a screenshot of that response from ChatGPT. There's a link to follow. I figured it should be put in front of us for a couple seconds at least, just to smile. I think it's remarkable how many strange things even ChatGPT assumes to be testing. And if the AI, if the large language model thinks it thinks all these qualify for being types of tests, then given it trains on a language of real humans, of whatever they post online, I would not be surprised if you see all of this in your day job or like on Reddit. So it's useful to at least know what sometimes people do refer to as testing. When I was preparing the slides, one theme was so recurring that I realized it should be on a separate slide. This message is that, like, look, your test should fail. The good test is the test that sometimes fails. If you write a test for any other reason, then having this test fail at a certain point in the future, you're not doing your job well. I mean, sometimes certain frameworks or languages or company policies have to do with, you got to have at least this percentage of test coverage for your code to go to production. And I'm one of those people who thinks it's a horrible metric, because it is a horrible metric. It never results in good tests. In fact, it gives you a sense of false security. You really want to be thinking about tests to the degree that I really want this test to fail at a certain point, because it's going to save me a lot of time and downtime down the road. Another way to phrase it in a more actionable terms, is make sure that when you design your test, try to make it easy for it to fail for the future. Don't try to make it super forgiving. Make it more fragile by design. And so that once it fails, you should have a spark of joy. Aha, my test is failing. Finally, there's some interesting work to do. That's my preferred way of thinking about that. Well, we need to talk about types of tests, primarily because that's what ultimately was the reason behind this episode. And as it always happens in software engineering and overall, there's no single dimension, there's no single axis along which you can just rank the tests. So I figured the best I can do for the world is to at least outline those dimensions of this multidimensional space. So it's not really like multiple orthogonal dimensions. People view tests as some cluster groups of what belongs together. But I think it's important to differentiate what axis could be used to compare test types to one another, and which axis would be like comparing apples to oranges. So, for example, by the end of this episode, if someone asks you, hey, is it a functional test or a unit test? Like, to me, it's nonsense, because functional versus non-functional or whatever, and unit versus something else, they're just orthogonal dimensions. It's impossible to even postulate such a question. And if you at least begin thinking in these terms, my job here is mostly done. I think it's a recurring thing. When I thought back to what we covered in the past couple of years, with databases, SQL, NoSQL, not a single dimension by far. With message passing, message queues, buses, Kafka, Rabbit, there's no single dimension. Microservices, we had a small chit chat before. Yeah, it's really not as trivial as clear cut. So let me try to map these dimensions. It's all my personal opinion. I could be wrong, although statistically I don't think I am in this particular case. There are a couple dimensions I've outlined quickly enough when I started preparing the slides. The list is by no means exhaustive. There is a good chance I missed something. There's a good chance some of these correlate highly. I don't care, as long as it sends a message across. So one dimension that I think is always the most important one is, who is a stakeholder of the test? Who is the person? Which team, or rather which department, is most happy once this test is failing? I got a slide for each of these, so I'll quickly go through and then we'll dive in. The second one is, what are you testing with this test? Testing for an off by one, for lack of an off by one error, is one thing. Testing for log contention is something totally different. Testing some user tab on your Android app actually results in certain API call. That's a third thing altogether. The third dimension is, are we testing for something trivial, the happy path? Should be called actually, the happy path. Are we testing for the happy path, or are we testing for some really non-trivial, non-standard, rare, once-in-a-lifetime disaster recovery scenario? Again, testing for happy path, I think it's what's usually referred to as a smoke test, which I think is a good idea. Like, if you want to have some test, if you want to spend 10 minutes writing a test, the best first shot is to build a smoke test, just so that it runs and you know it runs somewhat correctly. But designing tests that help you understand something really bad, some non-trivial scenario is handled correctly by your system in like a self-hidden environment, that's a totally different problem. It's very difficult. It's very different. It's where pretty much like proof-based testing comes into play if you really want it to be super safe. If it's like a nuclear reactor that needs to have some checks and balances, some guardrails. So like totally different dimension altogether. The fourth thing that I put here is whether your test requires extra inputs. In my book, what people call unit tests, what I call unit tests, is something super self-contained. So like it's an and. Everything should come together. It should be simple, it should be small, it should be no external dependencies, it should run within one tap from your IDE or something. It should run on CI/CD, like GitHub Action. That's a unit test. If you need to, for instance, run some script to generate some data, that's not a unit test. It's something beyond that. I was actually, when I was thinking about this in the morning, if you're like, I can imagine a test that certain enum values allowed for a protobuf follow a certain pattern. Like to me, this would be a unit test. If you do reflection of protobuf and confirm that all the values are like uppercase underscore snake, uppercase snakes, uppercase separated by underscores. To me, that will still be a unit test, even though you have to compile the protobuf, because it's part of the standard build process. It's already in your makefile, Maven, Gradle, or whatnot. But if you have to run your own script to generate some data, I would not call that a unit test right away. It might require custom setup for other people to actually run this. I mean, terminology varies. If your company has an established process, this could be a unit test, but in my book, it's already starting to look more like an integration test. So once I'll dive into this further, but basically it's a separate dimension, whether your test can run in a standalone isolated mode, or it needs some external data to actually be useful. And then the question of which data to use is also part of the test harness setup. You could like replay the traffic from the past week, but then the test today and the test a month from today are different tests. And it's okay for the second one to fail, for instance, because it contains new types of requests which you had not seen before. And the last thing on this slide is, how do you make sure this test is run often enough? For simple tests, we have tons of really good tools these days, like IDE integration, Git hooks, bonus points for not making your test random. That's a bad idea. You want them to be deterministic. But sometimes tests do require manual steps. It's not that it's impossible to automate everything, even though it's also true. It's just at a certain point it becomes infeasible. It becomes not cost effective enough to invest extra couple of weeks to save a couple of manual clicks. So like, to me, it's again a dimension and an axis in this multidimensional space of test types. We can now quickly go through a couple of those. So when it comes to stakeholder of the tests, that's a really big topic, because a lot of people, especially who are not like truly writing code, some engineers, like not all engineers write code, and in the high tech, in our field, a lot of people call it a test, but they may not mean what you think a test is if they're not truly engineers. So there could be a test where the test passing means that the security like analysts team claim that it's okay, like there's no bad traffic, there were no plain text passwords sent over emulated network connections, for instance. It's also a test. It's a good test, but it's not a test engineers would really care about. It's a totally separate conversation. Or you have designers for whom a failing test is a test where they try using the product they claimed to be used in a certain way, and then they realized like a screen is missing. Some data should be on the main screen, not like a tap away. That's also a failing test. It's also good, but it's not a test that we engineers, we developers call a test. So the bolded three thingies are the tests where the stakeholders are either developers, and I liberally include SREs and DevOps under this bracket. You guys are great, and you're also developers. The front-end engineers, they also are developers. It's just their work has more to do with complying with various newly emerging browser standards and APIs for like React, Flux, Vue, or whatnot. That's a different sort of pain. And so I think you guys deserve your own bullet point here. One thing I would actually include here, which is not truly an engineering realm, is product people. Because some product people are really nice to us engineers, and they end up writing technical specifications in a semi-formal language. Some of them actually speak formal languages. I've seen product people draw diagrams in Mermaid, or write scenarios that are similar to, like, that is almost canonical cucumber. No jokes, it's a proper language. So if a product person is nice enough to you to help you write technical tests, well, first of all, hug this person. They are super nice, it's rare. Second, at times the best way to deliver your message to them is to actually have them write the spec, or help them write the spec, and then show which test it fails. That could be the best way to send your point across. Hey, you know what, this spec does not work because this is the scenario which I can program. This is a scenario that does not pass your like higher level declared acceptance criteria. So let's get back to the drawing board. To me, these are also useful tests, even though they're not necessarily coded in a proper language. When it comes to what does a particular test for, a lot of times people do ask me, how is it different when a junior person writing tests versus a senior person writing tests? I don't think it's a single dimension, but this one is mostly correlated with this dimension. And basically the answer is, the more junior a person is, the more self-contained and local what the test would be. So like to me it's kind of clear. If you hire an intern and they build some clever data structure to optimize your search for certain element or whatnot, it's literally they're writing code that manipulates bits and bytes in an array. Well, you need to test this, but that's the most, like, it's as low level as you can possibly get in terms of testing for correctness. To me, it's a clear pure unit test. It's really good if this intern we hired tests their code through. I've seen this. It's really enjoyable to work with, but certainly it's a much more of a lower level problem compared to what like senior plus people deal with when it comes to testing. A small step up from here is when you have to test multiple components talking to one another. That's where I think a lot of mid-level people would say, oh, I can use mocks, and then I have this component and this component, and I can have component A evaluate component B as a stub, and have component A pass the test under the assumption component B does what it should do, and vice versa for B to A. There's no short answer to why do I not like it, but in my experience, like, mocking is too often abused because it gives you this false security that I'm always trying to get away from. Realistically, if these two components have to talk to one another, it's far easier, cheaper, better in the long run to actually have them talk to one another within the test. It's a kind of worms. I mean, if it's a mono repo, some people hate it. If it's multiple repositories, then different versions may be incompatible. How do you test that? How do you align these versions? But to me, these are good conversations to have. These are useful conversations to have. And in my vocabulary, once you start thinking in these terms, you're sorted in the area of integration tests. That's no longer a unit test. If you're lucky, you can still run it from your IDE as a unit test. If you're lucky, it still runs super quickly. It's still part of the CI pipeline. It's still like, you cannot merge a pull request unless it passes these tests, if you're lucky. But I would never call them unit tests. They connect multiple components together and they test deeper invariants. There's also one thing I forgot to put onto the slides here is I think the standard terms these days, they might change. Don't cancel me for that. The standard terms are black box and white box testing. So in one case, you pretend what you're testing is a black box and you're not allowed to look inside. In the white box setting, you actually send requests to the system, and not only you test the correctness of responses, you also have some transparency into what happens there. For example, if there's a database within a certain component, you can make API calls, verify the correctness through other API calls, but also check that the database does contain what it has to contain. And then you delete something and you make sure the database does not contain that. That's a white box testing procedure. In practice, if you want to have an integration test, chances are only one component is going to be a white box. The rest would be either black boxes or mocks, but it's a different conversation. Max, you also asked me before, should we talk about like linters and other static analysis tools? I would say yes, they certainly are parts of testing. I don't feel they belong here to a large degree, just because like it's part of like hygiene, much like you format your code nicely to respect your fellow engineers and your future self. To the same degree, you would probably want to run linters and stuff, static analysis tools, just to be safe. They hardly operate on a high level. I was recently introduced to this concept of architectural tests, and I'm still not buying into the idea. It's the static analysis for a large code base, mostly Java, I think, so that you can write like unit tests that check for invariants on the result of statically analyzing your code. It's like reflection on the higher order dependency diagram. I mean, it's a nice tool to visualize, to highlight what should not depend on each other, but does. But to me, it's not testing. Testing is something you need to clear. You need to be able to clearly identify what's good and what's bad, what's the success criteria, and why exactly the test is failing. So to me, like linting and stuff and static analysis, they don't quite fit the bill, although of course they should be talked about. Thanks for reminding me. And then once we go from integration tests, like again, it's my perception. I'm not claiming to be the source of truth or the authority here, but in my worldview, a proper end-to-end test is what organically emerges once you start testing more and more components running together with one another. So at a certain point, you end up with your PM saying, "Hey, this is really cool. Could you also add this step at the beginning and this step at the end?" So that this is actually something I can show off with to like a chief product officers, to the CTO. Hey, we actually have this pipeline and test it automatically end to end. And a good engineer would actually want to make it happen, not only for political PR self-promotion reasons, although those too, but also because it's really nice to catch these things early on. If your engineering culture is good enough that you have all the small steps put together, why not have it end to end? There is a tricky subtopic here. A lot of people start using the words functional testing here, and I've actually checked with a friend of mine. He has a startup right now, Alex, and he puts it really nicely. He says, functional tests are about what, not how. So if you're testing from the inside, your tests just verify that the way you've chosen to solve certain problems, certain subproblems, is correct. How do you do it? Well, you use this data structure, this connection between these two components, this source of truth for consistency, this database, this sharding technique, this leader election. Functional tests are about what exactly is your cost optimization criteria. What do you need to ensure your system abides by? I do buy this to a certain degree. There's a big theme arising in the community that this whole idea of functional requirements should be ditched, because it's never clear what are the FRs, the functional requirements, and what are the NFRs, non-functional requirements. It's like a conspiracy to sell more interview prep, as in like a lot of interviewers would actually ask about this, and a lot of candidates prepare. A lot of people who prepare for interviews know how to structure their answer to begin from FRs and NFRs. I really don't believe that, in a sense that, well, is latency part of the functional or non-functional requirements? Well, if your product requires low latency, it's certainly a functional requirement. You cannot accept a product if it's slower than you need it to be. At the same time, so a lot of NFRs can become FRs, and a lot of FRs can be ditched entirely. Like if you want to design WhatsApp, do you need to have this is typing notification? Well, it's a nice to have thingy, but if you want to build a competitor to WhatsApp, you don't necessarily have to have it in the first version. So like it's always a shady ground. It's always a personal conversation between teams and engineers and products, between the founders and the engineers, between the candidate and the interviewer. So the word functional has a bad rep, and I personally don't like it. But the only case I do use this word in is when it comes to helping outline what has to be done. What is the acceptance criteria for the system? And if you can formulate your test so that it tests for a certain acceptance criteria requirement for the product, for the end-to-end solution, I think it qualifies for a functional test. But seen in this light, a functional test, a test that qualifies for a functional test, could be a unit test, could be an integration test, could be a stress test, could be a performance test, could be a security test. So to me, these are orthogonal dimensions. That's what I'm trying to highlight here. Hope it's useful and understandable. I'm not too fast, right? Thanks, Fox. Quick note on why the happy path tests are really not the same as properly testing for corner cases. I'm not sure there's much to add here. It's just, I never understood the urge of people to write happy path tests. So it goes all the way back to my message that you should write tests so that they fail. If you wrote some code and you're proud of that, and you want to write the tests to show it does the job in simple cases, it's like you wrote a plus b, and you test that 2 plus 2 is 4. There are tons of corner cases here. What are their negatives? What if they cross 0? What if suddenly they overflow? Whatever. That's what you should test for. If you test for happy path, it's not really a test. If seeing these tests turning green gives you satisfaction, I urge you to reprogram your brain to test for something tangible. At the same time, there is a really useful utility in happy path tests. They serve as a wonderful piece of documentation for how to use your code. And I confess I'm guilty. Even when I see my own code from a couple of years ago, if I don't immediately understand how to use this piece of code, I look for it. I go into the test right away, because there's a good chance I have the first few test cases, first few unit tests would be perfect illustrations of what's the semantics of using this piece of code and what guarantees can I infer from that. So my preferred way of parsing the code that I have not seen before, or have seen a long time ago, would be to look at the code. If I don't understand it right away, I look at the tests. If that doesn't work, I read the comments and go to the documentation and stuff like that. And that's where happy path tests are really helpful. So I recommend writing them just for illustrative purposes, so to speak. But as tests, they are next to worthless, honestly. They're not even small tests. Testing for complex self-recovery scenarios, that's a totally different beast. Proof-based tests are my favorites, and if your system contains something that can fail in a remarkably convoluted ways, well, first of all, congrats on working on that. If you have to, chances are you don't have to. Use something else. Like, don't build Raft yourself, please. Unless you really know what you're doing, do not build Raft. A lot of other things like distributed transactions, you really don't need that. You're better off using a design pattern that avoids them entirely. But if you really have to do that, if you paid for that, and if you need to ensure they don't fail at the worst possible moment, they may need a really sophisticated test, down to proving invariants and testing them, like leaving white box level checks in production just to make sure that your logs are doing what you think they should be doing, etc., etc. It's a separate dimension, by all means. I don't think most of my educational listeners would need this. I do need to highlight that this is like the furthest away type of test from what you think a test looks like. It does not look like a regular test. It's a totally different conversation. And I think the fifth part here is whether your test requires extra inputs. Basically, if you want to make sure there's no randomness, there's no flakiness, you get two approaches. You can use synthetic data, and you can replay past traffic. Synthetic data, well, like technically, if you use random seeds, fixed random seeds to generate input data, your test is not random. Your test is okay, it's a kind of worms. If it's multi-threaded, you can't really know what the particular invocation brings. I think Java deliberately changed the order of traversal of hash map elements from run to run, from for loop to for loop, just to help uncover those issues. So I'm not claiming that if you have the same input, you're always guaranteed to have the same output. If your code is multi-threaded, there are tons of things that will pop out every once in a while. But fundamentally, oh yeah, and random seeds work differently on different architectures. If you think you have random seeds set to 42, my favorite number, chances are it's not the same sequence on Mac versus x86 or x64. ARM and AMD are different in their mathematics, oftentimes, for many languages. I was surprised to learn that. That's true. You may literally switch to a different machine type on AWS, or go to a different cloud provider, or your GitHub test runner would be generating different pseudo-random numbers than your local machine. So be careful with that. In fact, if I have to use synthetic data and ensure correctness, I would specifically use the algorithm I know to be deterministic and give it a random seed that I understand. The more interesting case is when you have past traffic. So you claim that your service runs in production, it has tons of data. Every, let's say, week, you cut off some part of this log, and this log becomes replayable as a test for the code for the next week. well, certainly logically speaking, the test that runs on the data from today is different from the test that runs on the data from last week. So on the one hand, it's reproducible. On the other hand, things change, and like protocols change, formats change. All I'm saying here is, again, this is a separate dimension. If you're talking to your team, or somebody from your team is talking to you, hey, I need to test this, and here's my plan. It's really more important to ask if this test they are talking about requires more data, be it synthetic or real traffic. It's more important to ask for this than to argue if it's integration, end-to-end regression, or functional, or whatnot. That's my main message here. Yeah, I want to talk about what do I call unit tests. To me, they are self-contained smaller things, but we covered that before. Yeah, this one is the last one. What is the mechanism that makes sure that your test is being run? To me, it's also one of these dimensions, one of the axes. Because in a perfect world, like every single test should be run on every single change. In a perfect world, people know how to make commits with minimal localized changes. In a perfect world, we either have a monorepo, yes, I'm a fan, or you have cross-repository like versions, links, so that you always have a snapshot of a guaranteed consistency in terms of code. If it's multiple repositories that come together, you join them, you stitch them by the proper commit hashes. You have like a version revision number at the top of that, so you always have a fixed set of code to work with. In a perfect world, once you make a change to this logically unified piece of code, once you make any change, however small, all the tests are run in the next second, and in the next 2 seconds, you know exactly what is failing. And don't get me wrong, we actually are not too far from this world. I mean, we're not close, but we are quite closer to it today compared to 15 years ago. Most IDEs support running the tests. Most editors would actually highlight, right, like before you run your code, they would highlight potentially failing tests, even before they try to compile the code. Like they would highlight that, hey, this would not run because you missed the type. But they would also highlight, hey, this test doesn't seem to work, before you even thought of running that. So that's really good. Most developer flows, like love it or hate it, but I think GitHub Actions are here to stay. And people like using them, even though they can be a pain to write. We have a lot of automation built into most successfully scaled workflows. That's a good thing. And again, Docker Compose, say whatever you want about Docker. I love the concept. I don't like the command line tool and the primitives and the data model, but I love what they did. It's unfortunately or fortunately it won because it was a better tool. So with Docker Compose, it becomes so easy to run integration tests. I want to say component tests, but it's confusing. It becomes far easier today than 10 years ago, thanks to Docker, to run tests that have to involve multiple components, because most teams would actually go an extra mile to make sure their current version is like shipped to Artifactory as a Docker container. So it's quick. It's self-contained, it's isolated, and it's totally reproducible. It's really good. On the front end, huge kudos to whoever is working on this. It's a huge pain for you guys, I know. Browsers and mobile devices are really, really different and really painful to work with. But again, we made a lot of progress in the past decade, and it's usable. It's far better. And same goes to the clouds. I personally don't like Terraform, for example. But the fact that you can, and most companies do have the means to run the tests literally by spinning up a production cluster near production, next to production, running everything there and then tearing it down. It's a bit too expensive to do this per every single commit, but if the stakeholder, see above, if the stakeholder for the test is the SRE team, the DevOps, they actually will do this every once in a while, and they have budgets because that's what matters for the company. If something is broken tomorrow, the number of minutes during which you can spin up a totally new production cluster in a different part of the world and have it up and running, that's a business metric that counts. So we are pretty good. As a planet, as a civilization, we've gone a long way, and we're still working on that. So yeah, all I wanted to say here is certain tests can be designed to be run automatically and super quickly per change. On the other end of the spectrum, certain tests cannot possibly be run on every single change because they are too heavy, too intertwined, too interconnected. And that's another dimension, orthogonal to functional or unit or integration or component or whatnot. Huge hats off to our frontend guys. I'm not a frontend person because thankfully we have far better people than me who understand how to deal with this. I'm incapable. But I did have to look into frontend testing at least 3 times in the past 8 years. And I see the progress. I remember writing Selenium tests myself, and even that was quite impressive back then. I almost did it last year until I realized Cypress exists, and it's even better. And I'm not even citing the most widely used names. I'm just saying the things that are conservatively safe words to say in this regard. I know there are better and more popular and more widespread techniques. So the point being, thanks to these tools, the tests that include front-end components can be viewed as self-contained, which is a huge step forward compared to 15 years ago. We used to have QA departments. I remember speaking with a person who had a career teaching others how to become QAs so that they could actually spend the next N years and earning a living for their family testing software manually. Well, that was really useful and important 20 years ago. Thankfully, we no longer have to do it manually because the world has improved. Rather, I would use this opportunity to mention that, taking this as the illustration, it's really hard to define a boundary between integration tests and end-to-end tests, because what if this same test is triggered not by a fake or real curl command that sends a JSON payload, or a emulated button tap on this real physical Android device that is tied to this particular test runner? From the logical standpoint, they are identical. One is just slightly more instrumented. And if your terminology suddenly puts them into far different brackets, to me it's a terminology issue, not the issue with how the world is. So hence my mission is to align this terminology. Yeah. A lot of people tell me one of my highlights is to have strong opinions and disagree with everybody, and then hopefully prove being right many years down the road. So I'm gonna share some strong opinions, for which I don't think I'll be punished badly. One is that I do believe that the way you reason about tests correlates largely with how senior you are. So when I interview people, and I know a lot of people come here because they are preparing for interviews, when I interview people, I don't often ask about testing, but when I do, I don't necessarily look at the response along the lines of, hey, this can be tested using this framework, or I can mock that. I look at the level of comprehension of what is the role of testing in the whole org structure, in the whole end-to-end ownership of this business domain by your team or your future team, or by your stream which your team is part of. This really shows. I'm not sure how good it is. I mean, I could be creating bias unconsciously here, but realistically, in my experience, statistically, this holds true. The degree to which you can own this domain is one of the strongest predictors of your overall seniority, which also is an actionable thinking, because it means that if you want to level up, the social lift here is to start thinking of better tests. And in most teams, unless there's an emergency, in most teams there is room for you to write better tests and shine. So why not? My second strong opinion is that if you look at all these approaches, I think the integration tests are by far the most important ones. Because, again, in my terminology, along this dimension of coupledness, below the integration level, you have single component tests. Well, that's kind of simple. That's kind of trivial. In most cases, it's not difficult to test a single component. And in most cases, if there's an issue in a single component, it will be localized quite soon, even if it's a production incident. So there's not much value in individual tests, because the same issue will be uncovered by a higher level test. So yes, please do write local low-level unit tests, even happy path tests for documentation purposes. But in my book, integration tests that test multiple components together are actually more useful in terms of bringing value to the company. And then again, strong opinion, above integration tests, when it's like more and more end-to-end, say with this like automatic finger tapping, emulating the tap on an Android phone. Like to me, it's mostly PR. To me, it's mostly showing off. Not necessarily bad. I endorse it. It's nice when your team has good PR in front of upper management, but I don't think they bring too much value for an engineer per se. Chances are, if they catch something, it would have been caught already during production, during deployment, during QA acceptance phase or whatnot. So like in my book, my focus is almost always on making sure if certain components have to talk to one another in a non-trivial fashion, I would focus most of my attention on testing how they talk to one another. I would focus on this first. I guess this number 2 for me would be like proof-based or exhaustive or model-based, property-based tests for non-trivial state machines. And these two would be like 1 and 2, like 0 to 9 and then 99 to 99%. Everything else is just nice to have. And I do have a strong opinion that a good end-to-end test stems from an integration test. A lot of people, well, I ranted about this before in the past, hopefully less than 40 minutes, that some people would argue that I need a functional test. Why functional? Well, because it tests the functionality. And then I need a functional test from scratch. What you have done so far are just simple unit tests and component tests and whatever, regression tests. I need a functional test. I never bought that. Like if someone speaks like this, well, there's some political play involved, or this person is just not competent enough in my book. Because if you really want to have a functional test that tests for the functionality, well, you must have enough pieces already, like put together already in your integration tests. Just combine them in a clever way, and you get your functional test in a way that engineers are happy to maintain it moving forward, as opposed to just seeing them as a hassle, because it's really hard to support this functional test written in some other language, practice, approach, or whatnot. Yeah. I think we're there. We may well have the first under 1 hour episode. Recap. Do think of tests up front. I never fully endorsed TDD, test-driven development. I was never against it. I never said no to that, but I never thought it's like a mantra to live by. Sometimes I do it myself. Sometimes when I feel like it's a trivial but mundane and multi-step process, I would just assume that for today I have a solid like 6 hours of coding. Here are my 3-4 steps. Here are trivial tests. I would expect that by the evening, all of them would pass. But I think to me it's a personal choice. I'm not married to TDD per se, as well as to BDD, by the way, behavioral-driven development. That's all situational. The next piece of recap is do think of what is more likely to break. I cannot stress this enough. Don't just write tests for the sake of writing tests. That's called documentation. If you want to test your code, try to test it in a way that eventually breaks. And when you have to test what you don't fully control, I usually have this luxury. I usually test the code that I understand fully, because my team wrote it, because we know exactly all the invariants. But when I have to work with some black box, with something I don't fully understand, I'd rather test it through. So that if their version changes and their semantic like colon convention is different, I'd rather have my test fail to be notified that, hey, migrating from like version 3.1 to 3.11 makes something like breaks some of my assumptions. So I better check myself. To me, that's maybe I'm paranoid, but I think that's what good engineers tend to be. Talk to your stakeholders, talk to your future stakeholders early on, because it's really strange if your team has strong testing culture, but your peer team just wants to deliver. It doesn't fly well. So you need to sell them on the idea that there are standards on your team, and okay, if it's crunch time, if it's rush to deliver, things happen. I understand, but if you're trying to introduce proper testing culture and your peer team does not, maybe help them so that they are on the same page. They'll thank you later. Even if they don't, it's still a good thing to do. So you're going to enjoy the process and the results, so why not? Yeah, try to make sure your tests run quickly. I still have nightmares, well, metaphorically speaking. Back at Google, actually, even though it's presumably a super strong edge culture company, we had a piece of code that had to time out and fall back after 5 seconds of an activity, and the test that the guy wrote was literally sleep 5. He was a staff engineer back then. And when I told him, hey dude, that's just wrong, he asked me, what do you want me to do? Put a constant there, like k 5 seconds equals 5? Well, in a way he was right. It let us launch, so it's fine. But I don't like it. If you can do it right, you better do it right. Mocking time and emulating state machines and pushing time forward and backwards, that's not really an issue in the modern world. It's not hard to build software that supports it natively ish. And yeah, last but not least, if you're thinking of tests as something you have to do and you'd rather not, well, I claim, I bet that if you change your attitude here, you would benefit in the long run. Tests can be fun. It's the mundane part about tests, in my experience, is to justify that you have to write them in front of the Scrum Master or whatnot. That's the worst part. When you know you need to write these tests, your team agrees, but then the rush to deliver is strong. And I've had examples in both directions. I've had examples where the team was strongly in favor of, hey, we cannot launch this until we test it, and the product owners gave in. But I've had examples where the message from the top was just, that's not code that goes to production. Why are you wasting time on that? Well, I guess both extremes have their places, but my point is that unless you're in that situation, if you have the luxury of testing your code, better do. It's gonna pay off, it's worthy, and it's fun. Last but in the worst possible case, if nothing breaks, thinking of tests would at least help you train your brain towards trying to identify those future failure scenarios, which is by itself an awesome exercise. Much like you don't just write code, you also read other people's code and help debug it. It makes you a better engineer. Thinking of better tests also makes you a better engineer. That's more fun too. Here we are. Yes, sir.
So, thanks a lot, Dima, for a beautiful presentation. That's, as usual, the highest quality. I guess there are three main questions that we could discuss. Let's probably, lay them down. The first one is, Dima, what do you think about the chaos engineering and the running production tests? So tests in production with the goal of actually failing the system. So-called injection of failure. So is it in your mind kind of in your work? Is it also fits the bill of testing, or it's quite different? Second, quite simply, what do you think about the way how we write tests? Should it be something like Gherkin as closer to the business language and the natural language, rather than kind of intuitive instructions? And the third one is also very fast. What do you think about the you did mention about stakeholders, but what do you really think about the communication between the product owner and the developer? Should they, for example, sit down? Could you imagine that they kind of sit down together and writing the tests together, especially if it's something business specific? So kind of three very different things.
The third one is the most interesting, so let me quickly cover first and second, and then we can start at lane war. So for the first one, yes, testing production, carrying the risk of bringing it down, does qualify for testing in my book, and I do endorse doing this all the time. I even tried to push doing this within Google. I didn't like it. But I mean, really, if anything, it's good discipline. You have to write better code. Most companies, if they are large enough, most companies have some dog fooding practices. So like the earlier version, it goes to internal users first, or maybe to select organizations that have opted in, maybe for discounts or something. And then like a week later, this goes to the general public. It's okay for your internal users to fail. Like they should fail. That's by design. Like I cannot possibly imagine, let's say, I don't know, Gmail, which is obviously used internally at Google too. I cannot possibly imagine internal Gmail users at Google not running a version that is designed to be more likely to crash. That's just like if they don't do it, they do. I think they do something wrong. I'm pretty sure they do it. That I don't have the data. So that's what testing in prod. For how and where to write tests, it's a big topic, but I don't think it's important. I've seen a lot of chat that, oh, I would rather have my test code next to where the actual code is, because I think it looks better. Well, if it's possible to do it this way, good for you. Once you dive out of unit tests, once it's multiple components, so it's integration in my book, it becomes less and less feasible to combine these together. I would say white box instrumentation, like if you want to expose some counters, for example, if you want to expose some debug endpoints to access the internal state of certain subsystem during white box testing, instrumentation should certainly be next to the code that is being instrumented. Yeah, absolutely. If you're testing the A to B communication, and you need to do some injections into B from A in order to get this white box instrumentation, I think it's wrong. Like it better be on the side of this B, next to where the data is. But I don't think the conversation about structuring the code is it's not a simple one, but it's also not a clear-cut one. I'm pragmatic. Like, does it deserve like hours and hours of tons of engineers to make a decision? I think they have better things to do.
I can quickly elaborate what I meant when I asked the question. The question was the way how we write the test specification. So I did see quite a few examples, and most of the examples in imperative way, that we're doing something, we have some prerequisites, then we do something, call our methods, and then we just assert. But on the we can flip it in a way that we write something like, as I mentioned, Gherkin tests, cucumber, carrot tests, whatever it is. We can write specification which is more like a declarative way, saying that we expect something to transit to something, rather than in kind of laying out in an imperative way. So I guess my question was, no matter what the type of the test, how we actually, how would you prefer to write this test? Is it there?
I'm glad you asked. Yes, I had this aspect of your second question in mind, but I was rushing to get to the third question. So thanks for stopping me. It needs some context because we talked about this offline a lot of times. We're in the same boat religiously. I'm a huge fan of the idea that for what has to be state transition, for what fundamentally is observed in the state transition, the code is far better to be functional declarative than imperative. So because testing provides a good grounds to illustrate this point. Because if you need to test some in terms of a state machine, and you need to program your brain to get into this machine and then articulate certain steps that make it go to a certain state, and then even if your test passes, a year later, quarter later, you'll have no idea what's going on. So the test is there, it's useful, but then in order to, like, once you make some changes, you need to fix the test. You would need to spend those extra hours making sure you're still deep inside the context. Like, I'm a big believer that one of the unsolved problems in engineering today is this transition, crossing the boundary from imperative to declarative and/or functional. To me, it's a shame that we have amazing tools such as Selenium, Cypress, Terraform, Docker, but we have almost nothing that teaches more people to use declarative constructs. That's a shame to me. It's like when you go to a database, if it's a relational database, you would use SQL. You don't write for loops, you write outer joins. Like people understand enough syntax and enough concepts to clearly not attempt to write for loops and pretend they have indexes, like with reverse lookups. They just write a SQL query. They outsource the task of doing it correctly to the SQL engine, specifically because they speak the language of SQL, and it's widespread. We need something like this in the world of observing the effective changes that a state machine goes through. We don't have them. I keep thinking of this in the back of my mind. Honestly, that's one of my weak spots, one of my kryptonites. Maybe we could come up with some ideas on how to put it together. Maybe even in the testing space. I would not be opposed to that. But like realistically, I'm old enough to know that these ideas, they're either fun pet projects, or they have to start from a real company needs so that you can find sponsors for them, and then you explore, you learn what actually are the pain points for the other teams, and then you go to prod with this like broader outside a particular project if it scales, if it's useful. I hope to live long enough for this to happen. That's my optimistic, hopefully really realistic answer here. And then your third question, yeah, go on.
Awesome. No questions, and let's probably touch briefly the last one. Do you want me to reiterate, or you're fine?
Well, let me echo it back to you, and you tell me if I got it correctly.
Okay.
That's usually a better way to converse. You're asking about what's the best protocol, what's the best medium, so that engineers can talk to product owners in a sort of more formal way when it comes to testing, so that they understand each other better. Well, the short answer is no. The best solution I found, it's again a holy war question, and I have to be careful to not take sides. Like PMs are useful. PMs are really good, because without PMs, business cannot communicate their desires to engineers. Engineers are really good at writing code. Engineers are really bad at understanding how small is the degree to which their code translates to business value. So engineers can write amazing code that is totally useless. And in order for us engineers to make enough money, we need to actually make sure that a decent fraction of what we write solves the problems that bring these companies money. So product people are those proxies who try to collect requirements from the founders, the product team, the market, focus groups and whatnot, and they try to translate this vision into technical tasks. Tests, as in fully formal functional descriptions of what has to be implemented, it's too much to ask, really. Like, if we could ask for that, we would live in a far different, far better world. You know, all these memes, like, what if MTV only played music for the past 25 years? We would have like Mars colonized already. It doesn't seem to work. So asking product people to talk to you in engineering terms is often too much to ask. My best strategy is to build relationships with those few product people who actually are formal in their thought process. But statistically, I'm usually in the domain of data, real-time, consistency, and that's where those people tend to cluster. So if you talk about product with a product owner who owns some like UX product feature, chances are they have no idea what data integrity is even about. When you talk about what's something not too confidential, of an example, when you talk about like, can folders be hierarchical? And if you move a folder from a chain of folders from the middle of this chain, if you drag and drop it to a different chain, which property should inherit from the old one, from the new one? Where does the fan out happen? If the chains are both long, does it mean that a single innocent drag and drop results in hundreds of potential change events? If you have to be talking about this, well, you will end up working with the product person who understands the product domain. It's impossible for engineers to understand the issues really well, and products just not catching up. So like, I guess the key is finding the right impedance match with the right product people for the right tech level problems. And at the same time, like, if you're developing front ends and what you're testing are Cypress thingies, it's hard to ask for more from a product person than just, these buttons should be larger, and when you press this, it should actually load this screen right away and scroll to this location. You don't need more, quite frankly. And them formalizing these things in a Slack message is about as good as you need. So it's you being too nerdy trying to extract formal stacks from there. That's where I am in my career. I'm not sure if it's the universally correct answer, but if you're fortunate enough to work with data where correctness is important, you also tend to be fortunate enough to work with product people with whom you can talk at this level. And the other product people, you just try to don't try to drag them into your territory, because they're not trying to drag you into their territory, thankfully. So just find smaller room for firm connections. Don't try to broaden it to have weak connection. It doesn't fly.
Thanks a lot. I actually came up with the fourth question while you were speaking. And the question was more like quite a few people nowadays, they think that there is a need for some kind of production drill philosophy, sort of thing. That means even though we shipped a feature to production and some time ago it did work, there is a chance that the new features that have arrived later nowadays somehow corrupted this functionality, or the corresponding, I don't know, data sources or microservices which should be treated as dependencies are actually producing something that our feature X is no longer works in an expected way, and it is quite difficult to kind of to figure out in non-production environment because of these, I don't know, because of the data, because of something. So the question is, are you considering that we should, not every, but kind of the rule of thumb that we should have a list of production drills that actually check this particular feature is still working, and the test might be not really. Let's probably put it kind of aside whether it's a automated test or manual test, but the fact that we over the time we actually repeating the same drill to make sure that in production this functionality is still up and running. So it's a bit on the same token of the question of my first question, but still at the same time it's a bit different.
Yeah, thank you for using the word microservice. Had you not, I would have asked right away. So are you talking about the problem when different microservices have mismatched versions? But look, this problem is not specific to testing. It's specific to the culture of using microservices. And I was thinking, I know how to answer it from the standpoint of best dev practices. Like I would just argue that, hey, if you use multiple repositories, then synchronize them. Like have a top level repo that has commit hashes pointing to each particular other repository, and then that's your release candidate, and then you can test it through. That's just philosophically, I think that's the correct solution. But in terms of testing per se, look, I think it's a conscious call of a company. If your DevOps don't enforce the impossibility of deploying incompatible versions, and most companies that use microservices don't go that far, then we have to take it at face value that this company's development culture is specifically about more local enablement at the cost of sometimes having to do expensive rollbacks. And I don't think there's a correct answer here. I mean, I would really prefer trunk development with a monorepo, or if it's not a monorepo because it's too large, I would emulate it in multiple repositories. And that's like my dream. If I ever have a full-blown company of my own, it's going to be like this. But I'm not claiming that's the only correct way to do it, and I'm not blaming companies that do it the other way, because, well, if they are successful, if that's what their customers are willing to work with, then if it floats their boat, if the business runs fine, who are we to teach them what's the better solution for them? So yeah, I guess the short answer is, like, if your development process allows for proper end-to-end testing of this, by all means do it. But I don't think it's about the testing procedure. I think it's about the whole release cut, release branch selection question. And that's the question to the SREs in DevOps, not to the test automation teams.
Great. I do know that I have already asked quite a few, but people, I guess one of the trickiest questions during the interviews on high positions, say for example, senior plus, I actually was asked, or I have been asked quite a few times during the interviews, how would I test the code, which is a concurrent code? So how would I test correctness of this code? And honestly, I'm still don't know the good answer. So I wonder what do you think?
I'm familiar a little bit with what Google did with I think I can talk about it because what I know is from conferences. It was developed and open sourced far after I quit. They have this idea that for C++, you can actually like instrument your code with some library, which would deliberately try to make sure whatever can possibly go wrong can go wrong. So like the level 0 of this is to try to load the machine on which you run the test, so that it just injects random delays to random threads, like organically-ish, so that your code tries different code paths. Google went further, and they tried to actually make sure that all the paths are enumerated in your execution trajectory. Testing multi-threaded concurrent code is a pain. Like, if it's an interview question, I would just give my honest answer of what I think the perfect world is. In my experience, it's the best way to pass the interview. And then like ultimately, once the interviewer likes you, they can start telling you how screwed up things are, and then you start talking about real steps you can take to mitigate those things. But realistically, look, the goal of testing is to uncover a bug. And first of all, for concurrent code, for testing concurrent code to be useful, you need to have the code that is designed so that it does not contain bugs, or hopefully has like one or two which you can find. If your concurrent, like multi-threaded code misbehaves and it's not properly designed, testing doesn't help you. What testing can do in this case is highlight how bad this code is. You just need to redesign it. I mean, there's no magic bullet, but there are tons of best practices on how to properly like have a DAG of your locks, so that whatever is more innermost cannot possibly lock the higher level stuff in. Like some rules should be broken. That's what engineers do to build high performance systems, like especially in trading. But I don't think testing is the right term here. It's either you believe either you claim that your code is breaking tons of rules, but you think the way you broke them is correct, and you know exactly what to test for. In which case you can instrument those. You can put like annotations. Hey, make sure that this lock contention is accidentally released in the wrong order. Test for this specifically, and have the test that you can have a random test that runs for 100 hours for this to happen once. That's perfectly fine. Or if your code is not designed this way and you have no idea what's going on, like really what you're testing is, hey, can I even trust this code? And then if the answer is no, you use your test to justify the need to rewrite this. You cannot fix it if it's too broken and whoever wrote it is not there to consult. Like I've seen things where in production code, the accidental error that brought down the server. There were many machines, so one of them dying was not a big deal. It's like a couple of 500s that the users see. I've seen cases where what was the issue, the root cause, is certain singletons not being thread safe. And the person who found that and fixed it, he's my good friend, and he told me one day, I think the issue is it was the singletons. I'm trying to find it, and it was a big company, so like the company really wants to fix it. He would be like double promoted if he does it. And then like 3 quarters later, he's like, I think I localized it. I think I can fix that. And then another quarter later, oh, I fixed that. It was a single one. So there's no simple approach. It's case by case, and every single case can literally be like taking dev years to isolate. So go figure. We may well be. Yeah, thanks.
Can I also ask? Just to add a few things. You mentioned it, but I still think it's worth talking about regression tests. And because sometimes they are just as important as unit tests or some other tests. Because if your compiler suddenly, after the small change, started working 2 times slower, I think you should stop this commit before it happened, and some other performance important things.
Yeah, that's delicate, because as a fan of reproducible tests, I would much rather not use wall type, but some other metric. So if it's a test, if for example you have your like database instrumented, if you have your service mesh instrumented, I would say that, hey, if suddenly the number of network calls you're making is growing by more than like 2%, you better explain why and raise the limits manually. That's okay. If you can afford to have a language that can properly measure how many times a certain function was called, I think that's one of the areas where managed languages are really, really good. Like with Java, with .NET, with C#, with Golang, you can actually, like, you can run the code slower but in a more predictable way, and you can compare the footprints before and after your commit. This I fully endorse. With timing, I mean, I had these tests, I built them myself many years ago, and then I commented them out because Semaphore on GitHub was having issues, and I don't think I've ever uncommented them. So like if it's a big company, if you're in charge of the testing team, if you have dedicated hardware to run this particular test, which you know is used only to run this particular test, so the numbers are comparable, like apples to apples, then yeah, I think it's a good idea. But to me, I guess it would qualify for a regression test. But to me, it's a specific form of regression test that is designed specifically to make sure there's no regression. Surprise. If we call these regression tests, yes, under these tight constraints, I would fully endorse them. But it's a slippery slope. Sorry for standard terms. Because once you start doing this, other people will start doing other things. And then suddenly you get page that, hey, my like Python Databricks pipeline takes 10 times more time compared to before. And suddenly the issue is that some index is being rebuilt. And then it's a liability, not a useful test. So yeah, for a bottleneck component that is written, has to be like low latency, that has to be high throughput, that is written in C++ or Rust or whatnot, yes, by all means, dedicated hardware, make sure there's no regression, useful thing. For something larger, debatable. I have no idea, by the way, how we're doing on time. I do believe we are past the 1 hour mark, but not by too much. Okay, we still have a chance of having the shortest episode recorded so far. Thank you for wonderful questions. This was energizing. Really means a lot to me. See you off the record soon, and see you on air for the next big episode.